Hi, this is Mr. Thompson, and today I want to do a couple of quick examples of double replacement reactions. We talked in class today about single replacement, where you have a single element, and if it's more active, it will replace another in a compound, and so we have a chemical reaction, we produce new products. Here we're going to be talking about I have two different compounds, and what's going to happen is the cations and the anions are basically going to switch places, and instead of just one element replacing another, we're going to have two elements replace each other, and so it's called a double replacement. So what I have here is I have three different examples for you, and I want to run through these. Now, I wanted to go ahead and do some of your examples from your packet, and I also wanted to do some examples that are written as words so we can get used to not only what it's going to produce, but also writing these as compounds and balancing everything. So let's get started. Very first one, ammonium chloride and mercury 1 acetate. Now, mercury is a transition metal, so it's got the Roman numeral that tells us the charge. What are these going to produce? Well, in a double replacement reaction, the cations are basically going to switch places. So the positive ions, that's going to be your metal and ammonium, they're going to switch places. And so it's real simple. What we assume you're going to get is ammonium acetate and mercury 1 chloride. Now, the tricky part is actually writing out the formulas, which we'll do in just a moment. If we look at the next one, calcium hydroxide and phosphoric acid. That is a base and an acid. And if you have a base and an acid react, they're going to neutralize each other. You're going to get a salt and you're going to get water. So we know water is one part. The other one, we're going to take the cation of the first one and the anion of the acid, and we're going to get calcium phosphate and water. For the third one, calcium bromide, potassium hydroxide. The second one is a base, but the first one is not an acid, so it's going to be the same as the first problem. We're just going to switch, and we're going to get calcium hydroxide and potassium bromide. Okay, that was the easy part. All we're doing is switching the cations, just basically trading places, which is why it's called the double replacement. Now, to actually write the formulas, this is where we're going to have to review what we've done previously. Okay, I have ammonium chloride. Ammonium and chlorine both have a 1 charge. Ammonium is positive, chlorine is negative. Mercury 1 acetate, both of those positive and negative 1. If I were to write those out, that's what I get. And it's going to yield, this is real simple, the mercury and the NH4, they trade places, and so we're just going to get ammonium acetate and mercury chloride. If we look at this equation, it's already, everything's balanced. We're finished. This one is done. So that one was really simple. Calcium hydroxide. Calcium has a positive 2 charge. Hydroxide has a negative 1. So I'm going to have to bring 2 of them. Phosphoric acid. Phosphoric. Ic means it started out as phosphate. Phosphate, PO4 with a negative 3 charge. Acids always come with hydrogen. So this is what I'm going to get right there. Make sure you have balanced these properly. Notice I put the hydroxide in parentheses. Notice I have 3 hydrogen. When they trade places, calcium phosphate, calcium with a +2, phosphate with a -3. We've got to get that balanced, and of course water. If you look, this equation is not balanced. We'll balance that in just a moment. Let's go ahead and write the formula for the last one, get that entire reaction written out, and then we'll go to balancing these. So we have calcium bromide, potassium hydroxide, potassium +1, hydroxide -1, bromide -1. But calcium has a +2. So when we write this out, we've got to bring 2 to balance that. And then calcium hydroxide, potassium bromide, built up just like this. Now our first equation is balanced, but our next 2 are not. So let's go ahead and let's look at the calcium hydroxide and phosphoric acid reaction. I need to balance this. So calcium hydroxide, I've got 1 calcium on the left side. I've got 3 calcium on the right side. I have 2 phosphate on the right side. I have 1 phosphate. So those look like they'll be pretty easy fixes. And then we'll just balance the water with our hydroxide, making sure we get the right amount. Same thing with the hydrogen. We end up needing 6 water. If you're still having trouble with this, make sure that you either email me or you come into tutorials and ask any chemistry teacher, and we'll go over these with you some more. For the last one is a lot more straightforward and simple. Okay, so all of that double replacement, but there is one last thing that you have to do. we have to make sure that these reactions actually take place, that they'll actually occur. For a double replacement, here is your rule. If all products, that's all the things we created on the right side of these formulas, if all of them are soluble, then you have no chemical reaction. So how are we going to check for solubility? Well, we have to go to the back of our periodic tables. If you don't have that, if you've downloaded the star formula chart, that would be really helpful. Looks like this. If we look in the middle, we've talked about the polyatomic ions on the left, we've talked about the activity series on the right. If you look right smack in the middle, it says solubility of common compounds in water. This is where we're going to check to see if everything was soluble. Notice at the top it says these are soluble compounds. On the bottom it says insoluble compounds. And both of them will include exceptions. So we really got to pay attention here as we look at this. Okay, so in our first one, the products that we had were ammonium acetate and mercury 1 chloride. If we look on our solubility table, we find mercury chloride and we find ammonium acetate, but it's not actually going to show that. So if we look right here at the top, compounds that contain, for instance, acetate. Anything, since there's no exception, anything with acetate is soluble. But now if we look down a little bit further, compounds containing chlorine. Okay, compounds containing chlorine are soluble with the exception of compounds of silver, lead, and mercury. So mercury chloride is not soluble. So it's going to fall to the bottom. It's going to form a precipitate, and that means we will have a reaction. We will, because both of them were not soluble. The next one, calcium hydroxide and phosphoric acid. They have calcium, phosphate, and water. Since we formed water, then the other part, even if it dissolves, that's fine. That is still going to cause a reaction. And of course, we know that acids and bases are going to react, and sometimes violently, so no problem there. Let's take a look at the last one. We have calcium hydroxide and potassium bromide. So we go back to our solubility table. Calcium hydroxide, potassium bromide. If we look on the solubility chart, we had calcium hydroxide. So we come down and we try to find hydroxide, and it's actually right down here at the bottom. So this chart is telling us, okay, hydroxide is insoluble, except, if we look at the exceptions, anything with NH4, the alkali metals, and calcium. So calcium hydroxide is an exception to hydroxide being insoluble, which means calcium hydroxide is soluble. I know that's confusing. You need to think about that and pay attention. Calcium hydroxide is soluble. And so the last one that I had was potassium bromide. So I look around here and I find bromine. There it is right there. Okay, bromine is soluble. If we look at the exceptions, none of them say potassium. So potassium bromide is soluble. And that means that both compounds were soluble. And therefore, that tells us that calcium bromide and potassium hydroxide will not react. There is actually no reaction that takes place here. Okay, I know those were 3 quick examples. Take what you've learned here. I hope you've written this down. Bring it back in class. We're going to practice with this tomorrow. You guys have a good night.